We're going to look at factoring some harder examples. I'm taking these examples directly off the Algebra with Pizzazz, page 99. And if you take a look at them, just a little step trickier. Now all of a sudden I have a variable here on the outside. Before, you would have seen something like this, a squared minus 9a plus 20. Now it's a squared and I have two variables in here and I have a different variable at the end. We're still going to do exactly the same steps. I'm looking for two numbers which multiply to the outside. So I'm looking for two numbers which multiply to positive 20 and add to negative 9. Instead of listing all the factors in my head, because I've done this so many times, I know that those numbers are negative 4 and negative 5. Right? Negative 5 times negative 4 equals positive 20, negative 5 plus negative 4 equals negative 9. So you can do this using decomposition. So I'm just going to decompose that middle term. I'll do minus 5ab minus 4ab. The key here is that these two terms have to be equivalent. So if this is 9ab, you've got to make sure that you keep those ab variables there. And then look at what happens now. Okay, I'm going to split my equation in half. The only thing I can pull out of here, I've got an a squared and an a, so the only thing I can pull out of there is an a. When I factor out an a, I'm left with a minus 5b. Again, I should have a minus 5b over here if I've done it properly. What would I have to put here in order to get back to negative 4ab? Well, I would have to put negative 4b, right? Because I'm just in my head, I'm saying negative 4b times positive a equals negative 4ab, and then let's just do the really quick check. That works. And does negative 4b times negative 5b equal positive 20b squared? It does. So I now have this term is the same as that term. I'm going to pull that out in front, and I'm left with a minus 5b. When I pull those factors out, what am I left with? I'm left with a minus 4b. So you've essentially factored that using decomposition. The only difference is here that you have to be really careful that you carry all the variables down. Previous examples, you would have had a minus 5, a minus 4, but if you just look at it by adding that 5b and 4b, you're actually just changing your final answer to 20b squared. Okay, so it's just a little bit more to pay attention to when you're factoring, but the steps are exactly the same. Let's take a look at this one. Again, following my rules, I'm always making sure, can I pull a common factor out? 3, 6, and 24 have a common factor. So I can pull a factor of 3 out in front. I'm left with a squared plus 2ab minus 8b squared. Now I'm looking for a number that multiplies to negative 8 and adds to positive 2. Again, I could do that whole list of numbers, but just to keep this short, I'm going to do negative 4 times positive 2 and just check that. Negative 4 times positive 2 equals negative 8. Negative 4 plus positive 2 equals, whoop, that's not right. Let's try it the other way around. How about 4 and negative 2? Positive 4 times negative 2 equals negative 8. Positive 4 plus negative 2 equals positive 2. So those are my right numbers. Again, just carry that 3 out in front. You can't disappear. So I'm going to rewrite this a squared plus 4ab minus 2ab minus 8b squared. I'm trying to save some space here. Okay, so using decomposition, I'm going to split this in half, leave that 3 out in front. The only thing that I can pull out of a squared and 4ab is a variable of a. I'm left with a plus 4b. I better get a plus 4b over here. What would I have to put in front of this bracket to make the product of these two numbers equal to negative 2ab? That would be negative 2b. I'm just checking. Negative 2b times positive a equals negative 2ab. So that works. And just check this. Negative 2b times positive 4b equals negative 8b squared. So that's correct. And now just carrying that 3 out in front, you could actually use square brackets if you wanted to, but that's okay. This is factor is the same, that factor is the same. I pull it out in front. I'm left with a plus 4b. What's left over? A minus 2b. And stick your bracket there. Oh, I don't even need that bracket. There we go. Okay, so that's how you factor that one. And of course, I'm putting all my equal signs in there. I should have done it over here. Don't tell anyone. Okay, likewise over here, I take a look at this one and I say, well, 7 and 28. First thing is there a common multiple there? There is. 7 is a factor of 28. So let's factor out 7. I'm left with a squared minus 4b squared. And from the last lesson, when we look at that, all of a sudden, I don't have a trinomial, I've got a binomial, but that's a square, and that's a square, and it's a difference of squares. So I can rewrite this as a squared minus 2b squared. So that's important. I'm just rewriting it as a number squared. That's the trickiest part. And then remember, for a difference of squared, it's what's inside the bracket minus and what's inside the brackets plus. And that's factored, right? And if I just wanted to do a quick check, I could, this would be a squared. This would be plus 2ab minus 2ab minus 4b squared. And then the 7, when I multiplied that 7 all back in, I would get to my original 7a squared minus 28b squared. So I get what I started with, and I know that my answer is correct. Okay, so you're always following those steps. Look for a common factor to pull out. If you can't, and it's a trinomial, look for things that multiply to the outside and add to the inside. Pull out a common factor, can't do anything. Look for things that multiply to the outside, add to the inside, decompose, get your brackets, pull a factor out. Common factor, difference of squares, and I can go right to the answer. I'll do 2 more, and that should be enough to get you started. Over here, I see 2, 12, 14. I can pull a factor of 2 out. Furthermore, I have x cubed, x squared, and x. So I can actually pull a factor of 2x out. And then what I'm left with is x squared minus 6xy minus 7y squared. Okay? Can't do anything further with this. So now I'm going to look for 2 numbers which multiply to -1 and add, or so multiply to -7 and add to -6. That's going to be -7 and positive 1. When I multiply -7 times positive 1, it equals -7. -7 plus positive 1 equals -6. So I'm just going to leave that 2x out in front. This time I'm going to use a square bracket. And I'm going to decompose that. So I'm going to say, I'm going to put the 1 first, because if I look at these numbers, I could go 7, 1 or 1, 7. The 2 7s beside each other would be nice. So I'm going to say plus 1 xy. This was xy. This has to be xy. Minus 7xy minus 7y squared. I'm going to split I'm going to decompose those terms. Got my 2x outside. The only thing I can pull out of this first term would be an x, and I'm left with x plus y. I better get an x plus y over here because these brackets have to be the same. That's the whole point. What would I have to multiply x by to get back to -7xy? I would have to multiply it by -7y. Let's do a quick check. -7y times x equals -7xy. Good. -7y times positive y equals -7y squared. So that's correct. Now this term and that term are the same, so I can pull them out in front. So I'm left with 2x square bracket, x plus y, x minus 7y. Okay? And then to make it look a little bit neater, you don't need to put the square brackets in. If you did, there's nothing wrong with that, but I do need to put my equal signs all the way up. Okay, so here you're pulling a common factor out first and then factoring using decomposition. I have a sneaking suspicion the same thing will happen here. I take a look and I have 9, 6, and 1, so I can't pull a coefficient, but I have x cubed, x squared, and x. So I could take an x to the power of 1 out of there. I can't take any y's because there's no y term here. So all I can take out of there is an x, and I'm left with 9x squared minus 6xy plus y squared. So now I'm looking for 2 numbers which multiply to the outside. So they multiply to positive 9 and they add to -6. Those numbers are going to be -3 and -3, right? -3 times -3 equals positive 9. -3 plus -3 equals -6. So I'm going to put my square brackets in. I'm going to decompose that middle term, minus 3xy minus 3xy. Remember with decomposition, the whole point is that these two amounts are equivalent, right? So negative 6xy is negative 3xy plus negative 3xy. Okay, and oops, square bracket, split it in half. What can I take out of here? Now I've got a 9 and a 3, so my greatest common factor is 3. I can also pull out a term of x. I'm left with 3x minus 1y. I hope to get 3x minus y on this side. What would I have to multiply 3x by to get negative 3xy? I would have to multiply it by negative y. Just do a quick check in my head. Does that equal that? Yes. And is the product of negative y times negative y positive y squared? It is, so that works. So now I have my two brackets, which are exactly the same. And I can pull them out in front, 3x minus y, 3x minus y. And what I recognize is these are exactly the same. So that's 3x minus y squared. Okay. So that's a look at the examples from Algebra with Pizzazz on page 99. I hope that helped. And let me know if you've got any more problems. Thanks.